Morning, everybody. Hopefully you guys had a nice day off yesterday. If you want to put in green check marks so I can see if you're with me, and then we will get started. If anybody has any questions from last day that they'd like me to go through, you go ahead and put those in. Anything from the learning guide or those, there was a couple extra sheets that I said you should look at. One that I want you to hand in from lesson 5, and then the other one was just for you guys and your practice. I could go through any questions there. I know Mrs. Wood probably just talked to you about this because she just mentioned it before I came into the studio here this morning, but just trying to wrap up everything in terms of marks for term 1. If you haven't written the test and it's not done by the end of the day, I'm going to put in a 0 for it because I have to just accurately sort of give your mark to the school. So that doesn't mean to say that you just never can write it. It just means that at this point in time, this is, what you've done. You haven't written a test, and I give you 0 for it. One other thing is the midterm learning guide. A bunch of you brought them in to the test and gave them to me, so I have them. Some of you submitted them online, which is great, and then a few of you haven't submitted them at all. So if you could submit those learning guides from the midterm, there's a little online assignment thing you could submit them. So if you could do that for me, I can then give you guys, give you marks for that, and then I won't have to put in 0s for that either. So some questions coming in, which is great. I will get to those for sure. I have a feeling that some of the questions that you guys will be asking will be really similar to other questions, kind of a little bit repetitive, some of the questions, but you'd be surprised how they throw in little curves and things along the way and can make these questions a little bit more challenging. So let's start with Jade wanted page 10, question 3, C and D. So I'm going to assume that's from the learning guide, and then Ava's lesson 5 extra practice I'll get to in a second. So page 10. 3. C and D. I did these last day, Jade, but I can just mention them real quick. Letter D was a really tricky one here. And the key for this, and we're going to do a few questions like this today actually, is splitting the question into 2 parts. And once you've done that, it becomes a little bit more straightforward. Just looking at the first half independently from the second half. So asking, are there any common factors amongst the 2 terms here and then here separately? So the first one, you have this 2x, and then this one, you have the 3y. You factor it out. And then both terms have this yellow x plus 2 and an x plus 2, so you pull it out. And then you're left with 2x and 3y. And letter C was a similar sort of process, except looking at letter C here, both terms essentially have a term here and a term here separated by a minus sign. And both terms have this 3x minus 1. So if you pull out the 3x minus 1, what's left? Well, I have a 4x here, and then I have a negative 1 here. So there's the 4x, and then there's the minus 1. We'll look at a few more examples like this today. So if you're still kind of a bit confused by it, there'll definitely be a few more today to look at that a bit more. While I'm on the learning guide, I'll get to Alex's question number 11. Page 11, 3B. Factor completely. Did I? Okay. This one's a bit tricky because it has the y squared in the back here, but the process is still the same. So let's go ahead and maybe I'll just write it up here. X squared plus 5xy minus 36 y squared. So when I have a question like this, if you want to think of it as just x squared plus 5x minus 36, these are the types of questions we did last day. So all there is difference is now I have y and y squared in here. So what I can do is just say, okay, my magic number, if you will, I don't know what else to call it, is this minus 36. I need to figure out the factors of negative 36, and they have to add to positive 5. So what are the factors of 36? What factors can I break 36 into? So 36, I got 3 and 12, but that's not going to give me 5, that's going to give me 9. I get 6 and 6, and if they're both negative, one has to be negative, one positive, because it's negative 36. Those are going to add to 0. That's not going to work. What other factors of 36 are there? How about 9 and 4? And I need to end up at positive 5. So if I went 9 and negative 4, so of course these are all being multiplied by one another. 9 plus negative 4 is equal to 5. That will allow us to break down this middle term. So I'm going to break the middle term down into positive 9 and negative 4. Now, it's 9xy and negative 4xy, and then negative 36y squared. So this was the kind of method that we did last day, where we wrote down the question, then we said, okay, we need to split this in half and pull out any common terms. So what's common between the first two terms here? Well, the only thing that's common there is going to be just an x. So I'm going to pull out an x and be left with x plus 9y. All right, I'm going to keep my question split in half, and then I'm going to say, okay, what's common to the second two terms? I have negative 4xy and negative 36y squared. I need to pull out a negative 4, and I'll be left with, a negative 4 and a y, because I have a y here and 2 y's here, so I can pull out a y. So what's left? I have x, and then 36 divided by negative 4 is positive 9, and I have a y. So I get to this scenario again where everything in the brackets is the same. That's why I pulled out a negative 4, because whatever's in the brackets needs to be the same. So both terms have this x plus 9y, and what's left is an x and then a minus 4y. And remember from last day, we kind of did the questions two different ways. And looking here at our factors of 36, we decided were 9 times negative 4. And that's what we ended up with here, positive 9 and negative 4. The only difference is we have this just y tacked onto the end. So that's kind of question we're going to run into. We'll probably look at a few more like that today. That's why doing these factoring questions is so important to do a lot, because I know just doing more and more questions doesn't really seem like it helps, but there's so many different little variations of these factoring questions that they can put in there. It's important to kind of be exposed to a lot of them before you get to a test or something like that. So that's why I asked you guys to do that extra practice worksheet. So yeah, so I think that's it from the learning guide. A few people are asking about extra practice, lesson 4 stuff. So let's jump down to that. Or lesson 5, sorry. So what was the first one? 6C, D, E, and 3K. What else? Factoring polynomials 3B. All right, 6C, D, and 3K. Let's start with letter 3K. So we're asked to factor each of the following completely. If possible, verify the factoring is correct by expanding the factors by foiling mentally. All right, so letter K, I'll put it up here where there's some room. We have 24 plus 10x minus x squared. Now, you can see that this is backwards compared to normal. So I'm going to rearrange it. Negative x squared plus 10x plus 24. So I've just rearranged it. Now, up to this point, everything we factored had nothing in front of our x squared term. But now, all of a sudden, this one has a number in front of the x squared term. So what I can do to make it look like something that we've done is I can pull out a -1, effectively changing the sign of everything here. So just factor out a -1. It changes the signs of everything, because if you distributed the -1 through the brackets, it would change the signs back. And then I'm just going to look at this part of the question, just ignore the -1 for now. So my magic number here is -24. I need to figure out factors that add to my middle term, which is -10. I'm always looking at that last number. So 24, just off the top of my head, 6 and 4 gives me 24. But that's not going to work. So if I went -6 and +4, that's not going to give me 10. If I went -4 and +6, that's not going to give me 10. So maybe we'll go with 12 and 2 should work. -12, +2. Because -12 plus 2 is equal to 10. And that's my middle term. So I'm going to pick these two. And using the little trick that we used last day, I'm just going to leave the -1 out front. If I go x minus 12, x plus 2, I should end up at the right spot. I could break down the middle term here like I did in the last question, but I'm not going to. So it just makes it a little bit easier if we know our factors and we can just write it, and we'll just go right to the solution like that. The only difference with this guy is we have the -1 out front, and because that negative's 1 there, it doesn't really change anything. It just means there's a -1 out front. So that's a good question. Thanks for asking. It looks like there's another one that's really similar to that. Right here, letter L is backwards as well. And then there's a few of the other letters here that have the wide squared term on the back. The one that I just did out of the learning guide kind of look like that. So essentially they're the same, except they just have a y on the second term. So that's why we're going to do lots of these to kind of encounter all of the different ones we might see. Letter 6, C, D, and E. Let's just jump down to 6. Good stuff. All right, so these questions are, I don't even know what to say about them. They come up a lot, and they're a little bit tricky, and I didn't do one in the lesson, so let's look at an example of them. Maybe we'll just start with A first, and then it'll make more sense to do the last 3 in a second here. So let's just start with a nice easy one. So A plus B squared minus 6 times A plus B minus 16. This kind of looks like questions we've been doing. So what I'm going to do is a little trick. I'm going to say A plus B. I'm going to let A plus B equal the letter X. And Ava is a step ahead of me. Do you use substitution? We do. So I have a feeling you probably watched one of the videos from the lesson or something like that, or maybe you've seen this before, but you can use substitution, and the reason we do that is anywhere there's an A plus B, we're going to put just an X in here. So there's an X, that A plus B and then it's going to be squared. And we're going to have minus 6 times x, and then we're going to have minus 16. So at this point, this question, x squared minus 6 minus 16, looks really similar to the questions we've been doing. So the trick here was this let the a plus b, everything inside the brackets, just equal a variable. I chose x randomly. It doesn't have to be x. It could have been, z or whatever you want. So now I have my number is 16, negative 16, my last number. Numbers that multiply to 16 add to negative 6. So 16, probably 8 and 2, that's going to give me 6. So I need a negative 8 and a positive 2. If I multiply those together, that works. And then negative 8 plus 2 is negative 6. So negative 8 and positive 2. So I'm going to break it down. I'm going to go x minus 8, x plus 2. I factored that thing. All right. Now when we get to the end, we think, I use the letter x to hold the place of this a plus b. So when I'm at the end, I should probably go back and put the a plus b in there again. So that's what I'm going to do. So anywhere there's an x, I'm going to write it as a plus b minus 8. It's my first bracket. And then a plus b plus 2 in my second bracket. And that is how we do that type of question. So they're all essentially the same. Sometimes when you get to this last step, you'll just have to combine a few like terms. That's going to be the case for letter D and E for sure. Maybe I'll do E, and then if there's any other questions, Abby had a question, 1F. I'll do letter E here, and then I'll get to that 1F. So I had 3x minus 7 squared plus 2 times 3x minus 7 plus 1. So what I'm going to do is I'm going to let 3x minus 7 equal a variable. Let's make it equal y. So I'm going to have y squared plus 2 times y plus 1. So this one's a little bit strange because we're trying to find numbers that multiply to 1 and add to 2. So it's just going to be 1 times 1, and 1 plus 1 gives me 2. Seems a bit weird, but that's just kind of how it worked out. So we're going to go y plus 1 and y plus 1. All right. At this point, I'm going to resubstitute in the 3x minus 7 everywhere there's a y. So I have a y here, and I have a y here. I have 3x minus 7 plus 1, my first bracket, and I have 3x minus 7 plus 1 in my second bracket. Now, I can combine my like terms here just to simplify this a little bit further. So I'm going to have 3x minus 6, my first bracket, and 3x minus 6 in my second bracket. Now I have the same thing twice. I could simplify this one further step, and I have a feeling this is how the answer looks. 3x minus 6 squared, because there's 2 of them. I could just simplify it even further. So that's a tricky question, very tricky. But not impossible. Most of the stuff there we've seen before, except for maybe some of the substitution stuff. So it's good that you guys have a chance to look at that type of question because they do come up from time to time. So I think Abby had a question. Lesson 5, 1F. Right here, x squared minus 6x plus 5. All right, so we need numbers that multiply to 5, add to negative 6. How about negative 5 and negative 1? Negative 5 times negative 1 gives me positive 5, and negative 5 plus negative 1 equals negative 6. So my numbers are going to be negative 5, negative 1. So I'm going to go x minus 5, x minus 1. I can check that if I want. Let's do a quick check. Make sure. So I'm just going to expand it. I'm going to go x minus 5 times x minus 1. I get x squared minus x minus 5x plus 5. X squared minus 6x plus 6. Is that what I started with? Sorry, plus 5. Is that what I started with? Yes. So that looks good. You can always check these questions, which is one of the really interesting things about this section is when you get to the end and you want to check to make sure it's right, you can just expand it back out and then you'll end up with, you should end up with what you started with. So, yeah, and that's the thing. Sometimes you'll just go through all the factors and one will just slip your mind. This one, especially because you were using both the negative 5 and the negative 1, doesn't really make sense when you're thinking factors of 5. You're probably like, well, it's 5 and 1, that's it, that's all there is. But you can't forget about the negative ones. Just kind of one of these things. And that's why we need to do some practice on these types of questions because they are really kind of varied in how they'll end up looking and sort of the steps are always the same. It's just they'll throw in some weird things and it just makes it look different and students get really confused. So you just need to be confident in the process and you should do just fine with these types of questions. I think that was all the questions. If I missed something, go ahead and just put into chat again. I'm sorry. But I have a feeling that's it. The lesson for today isn't a terribly long one. So we might have some more time to go through a few more of the more challenging questions here. I don't see anyone typing, so I'm going to go ahead and just jump into lesson 6. And if I've missed your question, we'll probably have time at the end. Sorry, Taylor's typing away. Let's see what we have here. Today is lesson 6. Thanks, Taylor. Learning Guide, page 11, 6A. For all integers for k, so k is this middle term, for which the x squared plus kx minus 3 can be factored. So we need to figure out numbers that multiply to negative 3. So what are the numbers that multiply to negative 3? Well, I can have negative 1 and positive 3. I can have positive 1 and negative 3. Are there any other factors of 3? I don't think there are. So those are them. So if I added negative 1 plus 3 together, what do I end up with? Well, I end up with 2. And if I added 1 plus negative 3 together, what do I end up with? I end up with negative 2. So it's asking, if this is factorable, this letter K in the middle here, what can K be? So factors of negative 3 are negative 1 times 3 and 1 times negative 3. The product of these things is always going to be negative 3, and the sum is going to be positive 2 and negative 2. So K can either be positive 2 or negative 2. If I had something like x squared, let's pick some random number like 5 times x minus 3. Can I factor that? No, there's no numbers that multiply to 3 and add to positive 5. So this just can't be factored. So if I have a 5 in the middle, I can't factor it. But if I had a 2, I could factor it. Or if I had a negative 2, I could factor that as well. So that's just what's the question's asking. What numbers can this thing have in the middle there that will allow us to factor it? Because not all questions can be factored. The majority of questions you'll encounter in this section can be factored, but not all of them. So don't be surprised if you encounter one that just simply can't be factored. It's entirely possible. Polynomials of the form ax squared plus bx plus c. The only difference between the questions we're going to do today and the ones we did last day are the letter A here is now in front. So everything we factored up to this point has looked like x squared minus 2x minus 3. There's been nothing in front of the x term, the first term, my x squared term. Now, all the questions we're going to do today have a number in front of the x squared term. So it's going to make these questions just a little bit trickier. There's just, the steps are the same though. So you just need to be able to kind of recognize it. So the first question here says use algebra tiles to factor this thing. So here we go. 3D plus 4. I think I was using blue tiles for positive things. There's 1D. There's 2D. There's 3D. And then 4. 1, 2, 3, 4. All right, so there's 3D plus 4. It's going to be a bit of a messy one. And then I have 4D plus 2. So there's 1D, 2Ds, 3Ds, 4Ds, and then 1 and 2 little blocks. Extend that down a little bit. All right. Essentially what we're going to do is just fill in the rectangle that these things make. I guess I could write down what these are. This is 4D plus 2, and this up at the top is 3D plus 4. So here we go. X, or D times D gives me D squared. D times D is D squared. D times D is D squared. And then D times 1 just gives me a D, gives me a D, gives me a D, gives me a D. All right, so there's my first one. Essentially, all of these are going to look the same. D squared, D squared, D, 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 and D. And 1, 2, 3, one more. D times D squared, D squared. There's a D, there's a D, there's a D, there's a D. All right, so that's the first 4 because they're identical. And then down here, I'm going to multiply this D by 1 and get D. And then this D times 1 is D. And this D times 1 is D. And then I have 1 times 1 is just 1, 1 times 1 is 1, 1 times 1 is 1, 1 times 1 is 1. And you do that one more time. All right. That was a big rectangle. So what do we have here? Well, these are all D squareds. These are all Ds. There's a D and a D and a D. These are all D squareds down here. These are Ds. And then I have 1, 1, 1, 1, 1, 1, 1, 1. So what do I have? What do I have in total here? Well, how many D squareds do I have? I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have 12 D squareds. How many Ds do I have? I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22 Ds. And how many 1s do I have? 1, 2, 3, 4, 5, 6, 7, 8. So there we go. We've expanded using algebra tiles. Now everything was positive there, so it made it nice and easy. But that's what I ended up with. So if I wanted to multiply 3D plus 4 by 4D plus 2, that would be equivalent to 12d squared plus 22d plus 8. So that's algebra tiles. What if we were to do the same thing using what I like to refer to as FOIL, or the distributive principle of multiplication? All right, what did I have? Well, I had 3d plus 4, and I multiplied by 4d plus 2. So FOIL says I have to take my first, then my outside, then my inside, and my last. So let's go ahead and do that. First times first, then my outsides. So I have 3d times 4d is 12d squared. 3d times 2 is 6d. And I have my inside. Four times 4d and 4 times positive 2 is 16d and positive 8. So first, outside, inside, last. I'm going to combine like terms. I have 12d squared. 6 and 16 gives me 22. And then positive 8. So all I've done is just combined my d's in the middle here to give me 22. Is that the same thing I had up above? Yep. So I've done the question two different ways, and they both look like they got me to the same spot. So I'm kind of happy with how that ended. There you go. Remember, what we're doing today is the opposite of expanding. So we're going to factor, and factoring is going one way, expanding is going the other way. So we're going to kind of work our way backwards today, see if we can get to where we started, given where we ended, if that makes any sense. So let's just jot down a couple of notes here. We can use algebra tiles to factor a trinomial when its terms are positive. So when my terms are all positive, life is good. If I had two trinomials, Alex, FOIL doesn't really work because first, outside, inside, last just implies that there's kind of 4 terms in total. So if I had two trinomials, you don't have to write this down, but you had like x squared plus 3x plus 6, and then I multiplied that by 2x squared minus 3x plus 1. I would have to go first times first, first times middle, first times last, and then second times first, second times middle, second times last. And then I would have to go the 6 times the first, the 6 times the middle, and then the 6 times the last. So making sure that every term got multiplied by every other term. It would give you a big mess of terms, then you'd have to combine like terms together. I don't think you have to worry about expanding two trinomials in Math 10 though. I think that be maybe a grade 11 thing, so shouldn't happen. So back to the algebra tiles. So we can use algebra tiles to factor a trinomial when its terms are positive. For example, 2x squared plus 5x plus 3. If you can arrange the tiles in a nice pretty rectangle, then everything should work out nicely. So hopefully you guys can see the kind of shading that's in here. There's some lines in here to separate these terms. There we go. So if you can put everything in a nice rectangle, I see that I have, if the width of this is x, and then the width of this is another x, and then this is 1, 2, and 3. And then this is x plus 1, so there's an x there and there's a 1 there. So if I wanted to write this, 2x squared, so there's x squared, and then 5 x's, there's an x, 2, 3, 4, 5, and then 3, 1, 2, and 3. If I can arrange it in a nice little rectangle, then I can factor this. And remember, when we're just multiplying these binomials together, we're essentially finding the area of a rectangle because it's just length times width. So the idea here is just area is length times width. If I can figure out the length and the width, if I know the area, then I can kind of work backwards. So that happens if everything's positive, it all works out nicely and life is good. This factoring with algebra tiles kind of falls apart a little bit when we end up with a negative term in there, and I'll just show you quickly how that works. This is kind of why I don't love using algebra tiles, because it doesn't work the same all of the time. So when we use algebra tiles to factor a trinomial with negative terms, we may have to use we call it the zero principle. And add pairs of opposite tiles to form a rectangle. So the example we're looking at here is 3x squared plus 5x minus 2. So I want to kind of, write this in terms of algebra tiles. So I have x squared, x squared, x squared, and then I have 5x. So there's 1, 2, 3, 4, 5. And then I have to put my negatives out back, so I have 2 of those. Now, I can't write it as a rectangle. So, I missed the last one, x tiles. I can't draw it as a rectangle with everything filled in. So what I can do is say, okay, if I take a negative x tile and I take a positive x tile, I can add both of those in to complete this rectangle, then it should be factorable because I've added a negative and a positive. When I add a negative and a positive together, they just give me 0 essentially. So I'm just going to write added 1 positive x tile and 1 negative x tile. And that completed my rectangle. And because I've added 1 negative and 1 positive, it's factorable. So it's basically where I'm just going to leave it. Not too many students love using algebra tiles, so I'm not going to spend that much more time on it. Ava asked a question, will there always be new formulas and methods for doing all of this? No. Everything we've learned up to this point can answer every question we're going to encounter. So this is it. This is just all the stuff there is. No more sort of new things. So the next example is expanding 3h plus 4 and then 2h minus 1. So you can expand it whatever way you want. If you want to expand it using algebra tiles, go ahead and do that. If you want to just expand using FOIL, then go ahead and do that. I'm going to use FOIL. That's my favorite. I'm going to go first. 3h times 2h is 6h squared. 3h times negative 1 is negative 3h. So there's my first, my outside, my insides. 4 and 2h is 8h. And then 4 times negative 1 for my last is negative 4. I'm going to combine my like terms in the middle. Negative 3, positive 8 together gives me 5 h's. And then the little negative 4 kicking around at the end there. All right, so if I start and work my way down, started at the top, worked my way down, try to get the color I want here, we call that expanding. If I started at 6h squared plus 5h minus 4, and I work my way back to what I started with, we call that factoring. So moving down is expanding, moving up is factoring. These things are opposites of one another. Expanding, you multiply, factoring, you figure out what you started with in terms of multiplication. So what we're going to do is what we've been doing, but we're just going to look at these a little bit differently, because if we have a term, a number in front of our x squared or our first term, our squared term, then we always have to do this method. So we can now factor our expanded binomial product by using factoring by decomposition. Now, oh my goodness, factoring by decomposition, that sounds terrible. We've done it already. We've already used this, so it's not new, but we're just giving it a name now. Factoring by decomposition is factoring after writing the middle term of a trinomial as the sum of two terms. Then determining a common binomial factor from the two pairs of terms formed. So again, this is what we've been doing. We're just going to give it a name. It's called factoring by decomposition. Now, the really easy questions that we did last day, where we can just skip right to the end, you can do those types of questions using this method. So when you get to a factoring question, if you're ever unsure, if you always use the method factoring by decomposition, it'll work all the time. It's just sometimes we can just skip a step in the middle and just kind of jump to the end. So let's look at an example. Did it get pushed down to the next page? It did. All right, so I'm going to factor 8p squared plus 5, 8 minus 18p. What I think, let's do this. Let's stay here. Let's take, it's not written on your page, but we'll take 6h squared plus 5h minus 4. Let's start with that, and let's factor it. So when I have a term or a trinomial in the form ax squared plus bx plus c, where a, b, and c are just numbers, what I'm going to do is, this is called the AC method. And what do I mean by AC method? Well, I'm going to take the letter A, and I'm going to multiply it by the letter C. And that's going to give me a number. So in this question, the letter A is a 6, and the letter C is a negative 4. So if I took A and multiplied it by C, that would be like taking positive 6 and multiplying it by negative 4, which equals negative 24. So what makes these types of questions different from the ones we did last day is there's this number in front of my squared term, and in order to factor them, I can't just look at the last term. I have to multiply the first term by the last term, and I get 24. So what are the factors of 24? And they need to add to my middle term still, which is positive 5. So factors of 24. I can get 1, negative 1 and 24. Is that going to add to 5? Nope. I can get 6 and 4. One of those is negative. That's not going to work. 24, 12 and 2. Negative 12 and 2. Those aren't going to give me 5. How about 8 and 3? That might work. I need to add to positive 5, so I'm going to go 8 and negative 3. So 8 plus negative 3 is 5. So that's the one I want. 8 and negative 3. So this is the decomposition part of this. I'm going to take my middle term, 5h, and I'm going to write it as two separate terms. So I have my 6h squared. I've picked this 8 and 3 because I know it adds to 5 and it multiplies to negative 24. So I'm going to break this 5h down into 8h and negative 3h. And really, if I just remember, if I'm going this way is factoring, and if I'm going the opposite way up, this is expanding. So if I combine my like terms, if I was doing the reverse method here, I'd just combine 8 and 3 together to give me 5, and I'd end up where I was. So that's all we're doing. We're just kind of working backwards. At this point, we need to separate the question into kind of two parts. So I'm going to put a little wall here in the middle. Just my little wall. I'm going to look at the first two here and say, is there anything common between those two? 6 and 8 has a common factor of 2. And both of these have an h, so I can pull out an h. So if I pull out a 2h from 6h, what do I have to multiply 2h by to get me 6h squared? So 2h times 3h gives me 6h squared, and 2h times 4 gives me 8h. Let me look at my other two terms here and say, is there anything common to these? Remembering that everything in the brackets needs to be the same. So what can I pull out of 3h minus 4 to give me 3h plus 4? Well, I can pull out a negative 1 term. Now both of these have this 3h plus 4, so I'm going to factor it out. And what's left? Well, I'm left in the first one with 2h, and I'm left in the second one with negative 1. And I could expand that to check, but there's no point in doing that because this is the exact same question that we just did. So if we look at example 2 up above, we started with 3h plus 4 and 2h minus 1. We expanded and we ended up with 6h squared plus 5h minus 4. If I start with 6h squared plus 5h minus 4 and I factor it, I should end up with the same thing. And do I? Yes, I do. It's the exact same process, just going the opposite direction. So if I had the magic ability to take this and just flip the steps, if I think about working up my page instead of down my page, it's the exact same thing as what I just did, except I'm going the opposite direction. So if it can be simplified, you still do the AC method. If you can get the number in front of the squared term, so the first term, to be a 1, then you do not need to do the AC method. The AC method only needs to be done if there's a number in front of your first term, other than 1. So let's look at a few more examples, because this stuff can get a bit tricky. So 8p squared minus 18p minus 5. The first thing I'm going to ask is, are there any common factors in my 3 terms here? Do they all share a letter or a number? Is there a common factor between 8, 18, and 5? There's no number that goes into all 3 of those. So I can't simplify it before I start. There's nothing common to all 3 of those. So what I'm going to have to do is say, there is a number in front of my squared term that is not 1. In this case, it's an 8. So that means I need to do we'll call it the AC method. I don't even know if it's called this. I just made it up. It's a good way to remember it. So remember when I go ax squared plus bx plus c, what I mean by the AC method is whatever terms in front of the first times the last. So if I take a and c, A in this case is 8, and C is negative 5. I multiply those together, gives me negative 40. So I need numbers that multiply to negative 40. And add to my middle term still, negative 18. So anyone think of anything off the top of their head that's going to work for that? 40, factors of 40. I can think of 4 and 10, 2 and 20, 1 and 40. Yeah, that's about it for now. If I need to add to negative 18, Ava's got it for us. Thank you, Ava. We have negative 20, and we multiply it by positive 2. That's going to give us negative 40. And if we go negative 20 plus 2, that's negative 18. So the factor we're going to use is 20 and 2. Now, if this were a question like we worked on last day, we could just say, and I don't want you to write this down, we could just go p minus 20, p plus 2. Those are my two factors, and I'm done. But that doesn't work here because I have a number in front of the squared term. And I'm going to leave that up there just so we can kind of verify that when we get to the end to see that the answer is not p minus 20 and p plus 2. So we're going to use the decomposition. I'm going to take my middle term, this negative 18, and I'm going to break it down into the two factors I chose here, 20 and 2. So I'm just going to rewrite 8p squared and the minus 5. And then I'm going to break down the middle term into negative 20p and positive 2p. Now I can switch the order of the 20 and the 2. It doesn't matter what order you write them in, it's still going to work out to be the exact same. So don't be afraid to write it a different way. It'll just work out a little bit differently. And then I'm going to separate these two things, put a little wall in here. You don't have to draw the little wall. It's just kind of there to remind us that we're kind of treating these halves separately. So I ask, is there anything common between 8p squared minus 20p? Anything that's common there? The greatest common factor between 8p squared and 20p is going to be 4 and p. So if I pull out a 4p, what am I left with? Well, I have a 2p, and then I have a minus 5. So Taylor asked a question here. Do you only do the AC method if there's a number in front of the p squared term? Yes, that's right. And it doesn't have to be a p, it can be any letter, but if there's a number in front that's not 1, then you have to use the method we're using right now. If you have a number that is 1, then you can do the way we did last day, just the quick way. All right, so I now say my brackets have to be the same on either side of my wall here. So I'm going to have to end up with 2p minus 5. But look what's here. I already have a 2p minus 5. So is there anything common between those two things? Can I pull anything out? This is where it kind of gets a little bit, I don't know if I call it weird or not, but there's nothing common between 2p and minus 5. So I can't factor anything out. But for the sake of the process, I need to pull something out. So what can I pull out that won't change anything? This is where it gets maybe a bit strange, and that's why we do lots of examples, because this does happen from time to time. What we're going to pull out is a positive 1, which seems really weird, because if I were to expand or multiply the positive 1 through, it wouldn't change anything. So what's the point of writing it? Well, remember when we get here, we have to take this 2p minus 5, they're the same on both sides of my wall, so I'm going to factor that out. And what am I left with? Well, I'm left with a 4p and I'm left with a positive 1. So I have my 4p, and I have plus 1. And that's my answer. Now, you'll notice that these two things are not equal. 2p minus 5 and 4p plus 1 is not the same as p minus 20 and p plus 2. Those are my two factors. So when we have something that has a number in front of my squared term, I can't just do the kind of quick method. Let's look at one more example here, and then you guys can have some time to work or do whatever it is that you do. So the question says 24h squared minus 20h minus 24. The first thing I do with any factoring question is I say, are there any common factors between these three terms? And in this question, there is. So we need to always pull out a common factor. So I'm going to even just write that down here because this one has a common factor. So look for common factor first. It's the first thing you need to do. If you took this 24, multiplied it by the 24, and did the AC method, you're going to get this big, monstrous number and try to factor it from there. It's just going to be a nightmare. So if there's anything common, pull it out. So what's common between 24, 20, and 24? The largest thing that's common there is going to be a 4. So 24 divided by 4 is 6. Negative 20 divided by 4 is 5, and 24 divided by 4 is going to give me 6 as well. So before I even factor, before I even do the AC method, before I even decompose my middle term, I've pulled out a negative 4 because it was common to all three terms. That's what factoring is. Is there anything common? Yeah, in this case there's a 4. So now I need to say, okay, I've pulled out a 4, can I factor it further? If I do the AC method and then break up my middle term, does it factor any further? So let's check to see if it does. So we're going to take our A and C and figure out what that equals. In this case, A is whatever's in front of my squared term, and then C is whatever's last. So negative 36. So I need multiply to negative 36 and add to my middle term. And in this case, my middle term is negative 5. Now, some of you may be a bit thrown off by this 4. It's just going to hang out front. We're just going to drop the 4 down. Everything's going to be just peachy. We're going to do the whole question. There's going to be this 4 hanging out front. It just continues on. It just, it's out there. Just hanging out. All right, so numbers that multiply to 36 and add to negative 5. 36, I can think of 36 and 1. That's not going to add to 5, though. I can think of 6 and 6, which gives me 0 or 12. So that's not going to work. And then I have 9 and 4. So I need to figure out a combination of 9 and 4 that gives me negative 5. So I'm thinking if I take negative 9 and multiply it by 4, positive, I get negative 36. And negative 9 plus 4 is equal to negative 5. So these are the factors that I'm going to use. Now you can write all the factors out, like 36 and 1 and 6 and 6. That's fine. But if you can just figure out right away what the factor is, you don't have to write them all out. Okay, so what I'm going to do is I'm going to take my middle term, and I've decided this 5, I'm going to break it down into negative 9h and positive 4h. That's all I've done is taken that middle term and I've decomposed it. Now the reason I've picked the 9 and the 4 is it's going to hopefully work out for us. If you want to think about putting this little wall in here to separate these two things, you can. If you don't want to write it in, that's fine as well. All right, this is where it gets a bit weird because we're going to have two sets of brackets, but nothing you guys won't be able to handle. What's common between 6h squared and 9h? So I know there's going to be a 3 and probably an h. So I'm going to end up with 2h and 3. And whatever I have in the first bracket, I have to have in the second bracket, else this whole process won't work. So I'm going to end up with a 2h minus 3 in the second bracket. So what do I need to pull out of that second bracket to end up with that? In this case, it's going to be a positive 2, because 2 times 2 gives me the 4h, and 2 times 3 gives me that negative 6. So I'm going to pull out that positive 2. Again, the 4 is just coming along for the ride. What's common between the terms? Well, this 2h minus 3. It has to be in there. So I have this 2h minus 3. And what's left? Well, if I pull a 2h minus 3 out of the first one, I'm left with this 3h. And if I pull a 2h minus 3 out of the second term, I'm left with a positive 2. And you can see that that 4 just hung along for the ride, and we didn't even do anything with it. It just gets pulled out at the very beginning, and that is the answer we end up with. And that's it. That's all. So how are we feeling about that stuff, guys? Do you want to maybe throw a thumbs up, thumbs down, smiley face, confused face, anything into chat so I can kind of get a feel for how we're doing with this sort of thing? Again, it's one of these ideas where you can watch me do it 100 times, but you may never really, get it until you've done it a few times. I can watch Michael Jordan play basketball, but I'll never be able to slam dunk from the foul line. It's just something I won't be able to do. So you need to get in there and try to do it a few times. And after you get some practice with these types of questions, it should eventually, work out. Once you get a few of them right, you'll get some confidence. The process is exactly the same for all of the questions. It sounds really crazy, but it's the same. You're going to do the same thing for every question. If you follow the method, you're going to end up with the right answer. So it's just a matter of you guys getting out and doing some of the practice. Where are we in the course right now? Let's look at the learning guide. We should be pretty well done all of them. You can see that question factor completely here. These have terms in front of the squared. So these are the ones that we looked at today. The long method, this is what we just did. I called it factoring by decomposition. They call it the long method. Perfect squared trinomials and difference of squares we are going to encounter tomorrow. So difference of squares, this is lesson 7 stuff. So really, this is why I don't love this learning guide. It doesn't really have a lot in terms of factoring with a number in front of the first term. So that's why I threw in some of that extra practice. Now, in the course, I added extra practice for lesson 5, but I didn't add any extra practice for lesson 6. I probably should, but I don't want you guys to do too many of these because you could be there for days doing all of them. Let's just allow this. If I look at the practice assignment here, you can see there's a ton of questions with the a non one in front of the first term. So I don't know. Let's pick one question for you guys to do out of these. That one looks pretty evil. Maybe off of the lesson 6, you guys can do question 2. So the lesson 6 extra practice. When I get back to my office, I'll put the PDF in there so you don't have to search for it quite as much. But if you guys can just do question 2, There's like 8 examples there. Just give you some practice at this stuff because the learning guide doesn't really have any questions on it in there. I think there's only 3 or 4 questions. So I can't stress how important this stuff is. It's kind of the idea from Math 10. It's a completely new idea that you've never seen before, first of all, factoring, and then it's just kind of like a new process you've never encountered. So you do need to do it a few times to get better at it. So yeah, doing some extra practice with this stuff is a really great idea. So if you, obviously the learning guide doesn't have a lot in it, have a look at some of the extra practice questions. The more you do, the more you're going to encounter in terms of these types of questions, the easier it's going to be when you come to a test or quiz with all of the different things that are going to happen. So that's kind of my recommendation to you is I'm not going to say you must do this whole sheet because that's going to take you guys a long time. But if you want to be successful with this sort of thing, the more you do, the better off you're going to be. Where are we in terms of the course? We did lesson 6. We're going to do lesson 7 on Monday, and then that's it. So there's just one more lesson, and it's a difference of squares, and it's pretty easy stuff. So the worst is behind us now. So that's kind of where we're at. We'll probably do that. I'll have you guys do the Unit 4 test either Tuesday, Wednesday, mid next week would be my goal. I think most of us are caught up, so everyone's in the kind of the same spot in the course, which is great. You can be just focusing on this Unit 4 stuff instead of the older stuff. That would be even better. So we'll aim for the Unit 4 test next Wednesday. I'll finish it off on Monday. Maybe we'll have some time to look at a few questions on Tuesday. But I can't stress it enough that you guys need to do these questions. You can watch me do them all day. I assure you I'm fairly good at them, make very few mistakes, but you need to figure out how it works for you. So that's all I'm going to say today and just leave it there. You guys are on with Mrs. Ward in about 10 minutes. She'll be here in the English room. So that's that. Hope you guys have a great weekend. Do some practice, come with some questions on Monday, and then we'll wrap up this unit at the beginning of next week. Thanks.